Hello everyone, welcome to today's video. I hope you're having a great day. I am Dr. WD40 and today we're going to be talking about evolution and natural selection. There are a lot of, misinformations, as you could say, regarding evolution. Some people believe evolution is point directed, but you don't evolve for a purpose. In evolution, it's based on what's known as descent with modification. Now, how does that modification turn up in the population? That's what we're going to talk about today. It chooses or selects naturally, natural selection, the differences that already exist in that population. So you don't have an environmental change and then something happened and then those organisms are like, oh no, we need to evolve. That's not how it works. It's already a difference within a variation within that population, and that organism can then survive and reproduce more. So let's get into this now. All right. So first, define natural selection. Natural selection is defined how organisms better suited for their environment tend to survive and produce more offspring. Let's write that out here so you can see it. The organisms better adapted. So descent with modifications. How do you become better adapted? You don't, it's just within the population. So organisms that can survive the environment they're in are more likely to survive within that environment. So more adapted to their environments. Oh, it crashed. Let's open that up real fast. And here we go. And we're back. More adapted to their environments tend to survive and produce more offspring. So this is easiest to see using examples. So popular example that you can use and that I'm going to use today is when you have different hair colors of, let's say today we're going to talk about mice living in a population and how easy it is for a predator to see them. So if you're camouflaged, and if you look at a lot of organisms, they blend into their environments pretty well. The ones that don't blend into their environments are more likely to be selected by that predator faster. So that's what we're going to show the example of today. So I have 3 little squares drawn here, and these squares are going to represent some changes within this population. So we're going to have something that happens here and something that happens here. So this initial population, let's say we have some yellow mice, which assume those yellow mice blend in pretty well. I just wanted to make it so you can see the colors a little better. So we have these yellow mice. Then we also have some gray mice here. So let's say there's also some rocks in this population, and these, so let's say this is a beach. So these gray mice can hide near the rocks if they see there's a predator nearby. So out here, let's draw a little predator out here. That's a bird. Don't mind my artwork. It's not the best. But here we have a bird in this population, and this bird is trying to eat these mice. But the yellow ones are blending in well with the sand, and these gray ones blend in well with the rocks. But however, an event took place where a volcano erupted. So we're on an island nation with a beach, and there was a lava outflow that came down and hardened on the beach, and the mice survived. So now, within this population, so this arrow represents the first change from one generation to the next, we can see the mice living on this lava flow now, trying to survive. So now, when we have this bird out here, so this bird out here is looking down here, and it's going to eat the first mice it sees. So most likely it's going to start selecting these yellow mice and eating them. And every now and then it might see a gray mouse and eat it as well. But mostly it's going to see these yellow mice first and eat them, because now these mice have to live on this lava outflow. So now say these mice are the survivors of this generation, and these are the ones that were able to reproduce. And let's say they each produce 2 or 3 offspring. So if we're drawing the yellow ones here, we'd have around 4, and the gray ones we would have a lot more. I'm not gonna count it out exactly, but you can see how much this population shifted now. So here the frequencies were about 50% yellow versus gray mice. Now in this population, it's now, 75% gray mice, 25% yellow mice. So now if we bring the bird back, it might select out these yellow mice now, and now the final generation, by the time you get to the 3rd or 4th generation here, all the yellow mice could be gone from this population. This initial population, so if this was population 1 here, was 50%, 50%, and everything was fine. And there was variation within that population, but so far there were no selective pressures against that variation. The natural selection is when there's a selective pressure against a certain trait in that variation. In this case, it was fur color. So here, when we have the selection event now, the yellow ones get selected out. So here, after the environmental change, the gray ones are now the most better adapted to their environments, and they survive and produce more offspring. So the gray ones now produce more offspring, and eventually we lose the yellow ones in future generations, and that's natural selection in a nutshell. So that's like the main example you see of birds eating mice. Next thing I want to talk about is antibiotic resistance. So we all go to the doctor when we get sick, and they might prescribe you antibiotics. And what do they tell you when you go to the doctor? They say, make sure you take all your antibiotics, even if you're feeling better. Now, why do they say that? So if you're feeling better, why should you take your antibiotics? It's because you want to kill as much as the culture of bacteria that were in your system at that time. So even though you're feeling better, there are still bacteria that persist from that original population. You're giving them a chance to divide. So every bacteria is it's about 20 minutes to double. So you go 1 to 2 to 4 to 8 and 16 all the way up. And so within a couple hours, 12 hours, you can be at hundreds of thousands of bacteria. And that's why taking all your antibiotics is important. So if we draw this first culture here, let's bring green out and draw some bacteria now. And this individual got sick. And there's the bacteria. Person took antibiotics, took them all after they were sick. So you took them for around a month and cleared out all these antibiotics. Everything was fine. Now, let's say this individual only took the antibiotics for a few days. They started feeling better, and they said, screw it, I don't need to take those anymore. Now, that person left a couple bacteria remain in that population. These bacteria are now going to continue to replicate, producing more of the green ones. But what you do when you allow that replication to continue is that you increase the chances of one developing a mutation. So every round of replication, you have to replicate the DNA. By replicating the DNA, there's a chance that something could go wrong. That something going wrong could be something going right in terms of bacteria. And when they replicate so much and produce so many generations very, very quickly, you increase your chances of developing that resistance much faster. So now, let's say this population of bacteria now infected another individual. Scroll down a little bit here. I made myself run out of space. So this individual now started taking their antibiotics, and all the green ones died. And now that the green bacteria died, it gave the red ones a place to flourish. It gave them space. It gave them nutrients. So now this person is wondering why these antibiotics aren't working, and now they're sick. Or they continue to be sick because they gave a space for all these to evolve. And, the antibiotics killed these, but not these bacteria. So now this is how, superbugs come about. So these are our super bugs. And it takes roughly 2 years for antibiotic resistance, pesticide resistance, things like that to develop. So pesticides, it's the same thing. They, spraying plants and, crops and things like that. Those insects and stuff are going through the same evolutionary process. So they're trying, if there's one in that population that has a difference among it, and that's what it's all about. Those bugs are not evolving to fight off that antibiotic or that pesticide. Those bugs have a variation within the population, and by allowing them to replicate more, it increases the chances of that variation from being selected for. If that variation is selected as being the best adapted for that population, it's going to be the one that takes over that population after a few generations. And that's the key to evolution. And natural selection. I know this was a short little video here. I hope it covered everything quite well. If you have any questions, make sure you let me know in the comments. And thank you for coming by. And I hope you learned a little bit today. All right, have a great day. Hello again. Thank you for watching my video. I'm glad you could come by. If you enjoyed this content, feel free to do that thing where you like and subscribe. Also, if you're interested, I prepare and record all of these videos live on Twitch. After the recordings, we do a post-recording question and answer section, and then sometimes I play games where any question is fair game as I game. Also, on Twitch, I'm a co-founder of a wonderful community called the Knowledge Fellowship, or TKF. Our goal is to seek and share knowledge with others while live streaming. We feature streamers who cover biology, law, physics, chemistry, geology, photography, health and fitness, psychology and mental health, rocket science and aeronautics, programming, and tons of different practical EDU streams. Feel free to check out TKF at the link in the description and join the very active Discord community. Hopefully, find something that interests you. With that, I'll see you all next time and have a wonderful day. Remember to seek knowledge and challenge everything.